Imagine the raw power of a volcanic eruption. Rivers of molten rock, clouds of ash blackening the sky. Now, picture this terrifying scene pierced by brilliant flashes of lightning. This isn't science fiction. It's a real and spectacular phenomenon known as volcanic lightning, or a dirty thunderstorm. It's one of nature's most dramatic and mysterious displays, a fiery light show born from chaos. But how is it possible? How can a volcano, a creature of earth and fire, create lightning, a phenomenon we usually associate with storm clouds? Today, we're diving deep into the heart of the eruption to uncover the secrets behind this electrifying spectacle. Join us as we explore the science, the beauty, and the sheer power of volcanic lightning. To understand volcanic lightning, we first need to understand the chaos inside an eruption plume. When a volcano erupts, it doesn't just spew out lava. It violently ejects a massive column of gas, rock fragments, and superheated ash miles into the atmosphere. Think of it as the ultimate pressure cooker exploding. This turbulent cloud is a chaotic mixture of particles of all sizes, from fine dust to larger chunks of rock. As these particles are blasted upwards and then churned through the air, they collide with each other at incredible speeds. It's like a cosmic-scale sandblaster. This constant, violent friction is the key. Just like rubbing a balloon on your hair creates static electricity, these collisions strip electrons from some particles and transfer them to others. This process is called triboelectric charging. As the eruption cloud rises and expands, something fascinating happens. Gravity starts to sort the particles. Heavier particles, like small rocks and coarse ash, tend to stay lower in the plume or fall back down sooner. Lighter, finer ash particles are carried much higher into the atmosphere. This separation of particles also leads to a separation of electrical charge. Typically, the larger, heavier particles that have lost electrons become positively charged and concentrate in the lower parts of the ash cloud. Meanwhile, the smaller, lighter particles that have gained electrons become negatively charged and are carried to the upper regions of the plume. The result is an enormous, billowing cloud with a positively charged base and a negatively charged top, essentially. A giant, dirty battery hanging in the sky. Nature always seeks balance. When this massive separation of positive and negative charges becomes too great, the atmosphere can no longer act as an insulator. The built-up electrical potential is released in a sudden, massive discharge of electricity, and that's what we see as lightning. These bolts can flash within the ash cloud itself from one charged region to another. They can also arc from the cloud to the ground, or even from the cloud out into the clear air surrounding it. The sheer energy is staggering, with a single bolt of volcanic lightning being just as powerful as one from a regular thunderstorm. It's a breathtaking and frankly terrifying display of raw electrical power generated by the Earth itself. So, are all volcanic lightning storms the same? Not quite. Scientists have observed a few different types. Some lightning flashes occur right at the base of the volcano, near the vent, almost as soon as the eruption begins. These are thought to be caused by the initial, incredibly violent ejection of material, which generates immense charge right at the source. Then there's the more common type that we've been discussing, which occurs higher up in the fully developed eruption plume. These plume-level lightning storms can last for hours, creating a continuous, dazzling spectacle as long as the eruption is feeding the ash cloud. The size, intensity, and duration of the volcanic lightning display depend heavily on the type of eruption, the height of the ash column, and the concentration of ash particles within it. You might be wondering, what about the thunder? Well, just like with a regular thunderstorm, volcanic lightning produces volcanic thunder. The rapid heating and expansion of air along the path of the lightning bolt creates a powerful shock wave that we hear as thunder. However, the sound of this thunder is often completely drowned out by the deafening, continuous roar of the volcanic eruption itself. So, while it's technically a dirty thunderstorm, it's often a silent light show for anyone watching from a safe distance, with the volcano's own soundtrack providing the bass. The visual, however, is what truly captivates. The stark white or blue flashes of lightning illuminating the swirling dark gray ash cloud create a scene of apocalyptic beauty, a dance of destruction and creation. Studying volcanic lightning isn't just about admiring a cool natural phenomenon. It has critical real-world applications. The presence and intensity of lightning can give volcanologists valuable information about the eruption in real time. For example, a sudden increase in lightning activity might indicate that the eruption is becoming more intense, or that the ash plume is reaching higher altitudes. This is crucial for aviation safety. Volcanic ash is extremely dangerous for aircraft. It can melt in the heat of a jet engine and then resolidify, causing the engine to fail. By monitoring lightning from a safe distance using radio wave detectors, scientists can track the location and hazard level of an ash cloud, helping to reroute flights and prevent potential disasters. The lightning acts as a natural beacon, signaling the unseen danger within the clouds. So, is volcanic lightning a sign of catastrophe or just a natural wonder? The answer is both. It is an undeniable catastrophe for anything in the volcano's path, a clear signal of immense destructive power being unleashed. The eruption itself is a hazard, and the lightning is a direct product of that hazard. Yet from a scientific and aesthetic perspective, it is a breathtaking natural wonder. It reveals the intricate and powerful physical processes that govern our planet. It's a rare event that combines geology and meteorology in the most dramatic way possible. Seeing a dirty thunderstorm is witnessing the fundamental forces of physics playing out on a gargantuan scale. It's a stark reminder that even in its most destructive moments, nature has a way of creating scenes of profound and terrible beauty. These electrifying displays have been documented throughout history, though it's only in recent decades that we've begun to truly understand the science behind them. From the eruption of Mount Vesuvius that buried Pompeii to the 2010 eruption of Eyjafjallajökull in Iceland that grounded flights across Europe, volcanic lightning has been a consistent companion to major eruptions. With modern high-speed cameras and advanced sensor networks, scientists can now study these events in unprecedented detail, capturing the intricate, branching patterns of the lightning and measuring the electrical fields they generate. Each new eruption provides a natural laboratory, offering more data and deeper insights into this shocking phenomenon. Volcanic lightning is a perfect example of how interconnected our planet's systems are. It's where the solid Earth meets the atmosphere, where geology creates meteorology. The friction of rock creates an electrical charge that rivals a supercell thunderstorm. It's a powerful testament to the fact that we still have so much to learn about the planet we call home. The next time you see footage of a volcanic eruption, look closely. Amid the smoke and fire, you might just witness one of nature's most spectacular and violent light shows. It's a reminder that our world is dynamic, powerful, and full of shocking surprises. Thanks so much for joining us on this journey into the heart of a dirty thunderstorm. If you found this as fascinating as we did, be sure to hit that like button and subscribe for more deep dives into the wonders of our world. And let us know in the comments what natural phenomenon you'd like us to explore next. Stay curious, and we'll see you in the next video.